Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes. Yeah, can anyone please confirm? Is my voice clear
Yes, sir, it's visible and audible.
Yeah, it's clear.
or not? Hmm. So in the last class, just I was briefing you about big that is Hadoop, right? Hadoop introduction. So like drawbacks with the current databases, Hadoop advantages, Hadoop services, Hadoop advantages, and Hadoop and okay, I didn't discuss much about Spark yesterday. Just I'll be briefing you about Spark also, right? Mostly used today, very high speed processing, right? Yes. So just I'll also just provide you some introduction to Spark also, right? Because Spark has got a very high boom today, right? So mostly used various. So here, what is Apache Spark? And why this PySpark required need for PySpark and mostly like Spark implemented using Python and Scala, right? Yes. And why Python and Scala, which is preferred more, and PySpark features real life usage and PySpark job market, you can check. Yes. Mm. Spark, Apache Spark, right? It's a open source. Apache Spark is an open source distributed cluster computing framework, right? Which was introduced by Apache Software Foundation. Apache Software Foundation has introduced this. It's an open source distributed cluster computing framework introduced by Apache S. It is a general engine for big data analysis, for processing and for computation, right? Yes. So it was developed in the year 2009 in AMP Lab Berkeley in the year 2009. It was open sourced in the year 2010. Was donated to Apache Software Foundation in the year 2013. So Apache Spark is an open source distributed cluster computing framework with in-memory computing feature. This is the main feature we see, right? In-memory storage in the memory level and processing in the memory level. That's why very high speed you see, right? It's a parallel process style with used for large scale data processing. So parallel process style, in-memory computation, distributed cluster computing. It's an open source. And why PySpark? Why PySpark today? So it is a Python API to use Spark. PySpark is a Python API to use Spark. So it is a PySpark is a lightning fast technology that is designed for fast computation. It's a very demanding tool among the data engineers, right? PySpark for work with bigger data sets. It is used for creating data pipelines, for ingesting data into database, running ML algorithms, working with graph and data streams, right? See, generally, why we need to go for PySpark, right? So if you see today, data is getting generated, keeps on generating huge data, right? So through, okay, the data has got many hidden patterns, unknown corrections. It has got a trends, market trends, yes, and customer preferences, what the customers are preferring, right? And other useful information. So we need to extract that data, right? That information from the raw data. So we require some efficient tools to perform this type of operations on huge data. So there are various tools already available to perform this kind of operations, but they are not that much fast, efficient, right? So we need some flexible tools to crack this big data, right? So PySpark is such a kind where we are combining Spark and Python. We are just combining Spark and Python, which is the very efficient way for the world of big data. So Apache Spark community came up with a tool called PySpark, that is Python API to use Spark. So if you see Spark is coded with multiple languages like Python, Scala, Java, and our language also. Multi-language support, but mostly used languages are Scala and Python. If you see the difference between Python and Python has got, if you see, Python has a bigger community as compared with Scala, right? Python has got a bigger community. It's an open source and has a huge community, right? Python community, 89,300 modules provided by Python, right? As Python has got powerful libraries for data science, for graph algorithms, for streaming these things. Even Scala also has got libraries for it. And yes, for especially for data science kind of environment, Python has got powerful libraries for this graph algorithms. And if we talk about the real life usage of PySpark, we see in the commercial sector mostly used today for real-time processing in banks and financial fields, they use Spark, right? This PySpark is used to retrieve the customer's profile and social media's information, right? Yes. In even in healthcare, right? PySpark is used today, right? To check the patient's records along with their previous reports to identify which patient is likely to face this kind of issue, right? Even after being discharged from the hospital, right? And even in the PySpark today has got mostly used in the entertainment industry, like for example, like OTT platforms like Netflix using PySpark, right? It is using Spark. So it's a for personalized online movies and web series, right? So this PySpark, it processes approximately 450 billion events per day, right? And even for trade and e-commerce like Flipkart, Amazon, all this they use this Spark, right? For advertising, for recommendations. People who purchase this product also purchasing other products, some kind of recommendations, right? For enhanced customer experience and improving the performance, right? Yes. Even if you see the job market, if you see the PySpark job market, you see huge jobs. If you just check PySpark jobs in the Google, right? Yes. And if you see the salary packages of PySpark as compared with other technologies, like huge packages for PySpark, right? Yes. 6,937 PySpark job vacancies in Bangalore. 728 PySpark job in 4th February, right? Mm, PySpark developer jobs, PySpark jobs available. Even like Hadoop and the PySpark, Hadoop jobs, Hadoop and PySpark jobs, right? 2,000 Hadoop job vacancies in Hyderabad, 2,000 Hadoop job vacancies. Data engineer, Hadoop, Infosys, Hadoop system engineer. And here, 1,000 plus Hadoop developer jobs in Hyderabad. Okay, you can just check, but okay, whatever it is. But if we see that big data engineers, right, the salary packages will be more as compared with the other technologies where you require some, even as the package is more, even the skills, technical skills related should be, you should have great command on this one. Yes. So if we see this, 1 second, if you observe this, if you see that entire PySpark, we see the PySpark course content, right? You can compare with any other training sites. We'll be revealing in brief PySpark sessions, context, parallels, repartitioning, broadcast, accumulators, RTDs, computations, actions and transformations, persistence features, persistence options, PySpark core computations, creating Spark objects, increasing the number of partitions, groupings and aggregations. Various types of single groupings, multi groupings, multiple aggregations, right? Process various actions and transformations one by one in brief. PySpark data frames concepts, data frame API, right? Creating data frames, RTD to data frame conversions, row class, column class, select, collect with column renamed We have got all this with many working examples, map, flat map, and we have got PySpark SQL functions. We don't need to write huge codings here. We have got many built-in functionalities. You need to know which one to apply when, for which purpose, what to be applied to perform the operations. Aggregate functions, window functions, data and timestamp functions, JSON functions, reading and writing JSON files. PySpark built-in functions, again, we have got when expr, lit, split, substring, translate, overlay, date, diff, o, explode, array, collect map, map keys, map values, struct, count, distinct. So in this way, an external sources, right? And working with pure SQL statements like Spark SQL, we say, and with Hive integration, with MySQL integration, with databases, and with working with CSV, JSON, transformations and actions, narrow and wide, adding of new columns, dropping columns, handling nulls, writing data to the external sources, creating tables from the data frames, PySpark applications, stages and tasks, drivers and executors, building Spark applications, pipelines, developing Spark applications to cluster and tuning, performance tuning, PySpark streaming concepts, integration with Kafka, PySpark machine learning. This everything will be covered. Apart from this, I said, apart from this PySpark, you'll be given knowledge on this Hadoop also, right? The components, the Hadoop components, right? Which are required. There are many Hadoop components, but the only things which are mostly used in the industry, right? Hadoop, like for storage, like HDFS for distributed file system, and MapReduce for parallel execution model, Spook for importing and exporting data, Yarn, yet another resource negotiator, Yarn architecture, the total how the processing is going to happen, and one NoSQL database like HBase, and also like streaming technologies, Hive, which is an important tool for data warehouse kind of environment for making the data structured, forming, creating tables, internal, external tables, working with Hive tables, unstructured data, working with XML data, JSON data, URL weblog data, inserting files, HDFS files, user-defined functions, tabular functions, aggregated functions, partition, tables, non-partition, performance tuning mechanism, bucketing, indexing, right? These things. In brief, it will be discussed. Apart from this, people who choose with Python package, right? Yes. When Python also in brief, it is going to be covered, right? Yes. This one, you can see later I'll show you, right? The Python content also. But yesterday I was just briefing you about this drawbacks with the current databases. So databases, so Hadoop it's provide for meant for storage and processing. For storage, doesn't use any database. It uses Hadoop distributed file system for processing MapReduce. So it is meant for batch applications. Spark meant for batch processing, batch applications. Batch applications means user non-interactive applications. User nowhere required, right? Yes. And next I was briefing you about the drawbacks with the current databases. No parallel processing in most of the databases. Limited storage. So even if complexity increases, speed decreases. Some examples related to that. They can handle only structured data. They cannot handle unstructured or semi-structured data. And this Hadoop follows master and slave, not client server. It's not like doesn't perform any request response. We are not performing any web applications. We're not developing any web applications here, batch applications, right? So, and micro batch applications also using streaming components. And here, there are two types of node, master and slave node. Master node for assigning tasks, balancing the load. If any absence of any slave goes down, the task has to be assigned to other thing, health monitoring, and slave nodes for storing and processing data. Advantages, main advantages of Hadoop, unlimited data storage, very high speed processing, can handle all varieties of data, structured, semi-structured and unstructured. It's an open source, no licensing required, commodity hardware. Yesterday, we were seeing that there were some tests conducted to check the speed of Hadoop as compared with the other things. Where taken data of 100 TB consisting of 1024 columns. Sorting based on 16 columns, right? So Oracle has taken 3.5 days to process. MySQL has taken 6 days to process. Teradata, a specialized database, which used just taken 4.5 hours to process it. Netija has taken one more specialized database for data warehouse purpose. It has just taken 3 hours, right? Hadoop, it has just taken minutes of time. The databases like taken days and hours, but Hadoop taken 3.4 minutes. Latest version of Hadoop has taken 1.2 minutes. This is what Hadoop speed. But if we compare this Spark speed, right? PySpark. Already Hadoop has taken in minutes, right? PySpark is 100 times faster. Spark is what? 100 times faster than Hadoop. See the speed of that Spark, right? That's the reason like Spark is mostly preferred, right? But there are some components in Hadoop which are used in that industry, right? Like Scoop is used mostly, Hive is used mostly for storage, like HDFS is used, NoSQL database is used, right? And why databases, that is why I'm going to cover as part of this. And why databases like Oracle won't support unlimited storage. Databases, right? They have got some limitation. They cannot go beyond that level, right? Like 250 nodes or 256 slaves. All these databases, they can go max of 256 nodes or slaves. Specialized databases which are used for data warehouse purpose like Teradata and Netezza Vertica, they can have 1,000 systems, 1,024 systems can be connected, right? Beyond that, they cannot support. So there is no limit on the number of nodes or slaves that Hadoop can have, right? Yes. Yahoo, when first time implemented Hadoop, went with 4,000 slave systems. Currently, Yahoo going with 12,000 slaves. Facebook, when first time implemented Hadoop, went with 8,000. Now it is going with 42,000 slaves. So I was saying yesterday, Hadoop follows master slave architecture. Single master, multiple slaves, right? Group of systems connected in network. We call it as a cluster. This is what Hadoop cluster. This we call it like master node. And we got a name node, we say. In Hadoop terminology, right? Name node. This we call it like slave nodes or data nodes, we say. Data nodes. Data is stored by the slaves, data processed by the slaves, right? So, next, slaves, right? Yes. Just 1 second. Okay. In Hadoop, data is stored in the form of files. In databases in the form of tables, but in the Hadoop in the form of files. This file, a big data file cannot fit into a single system, right? So it will be splitted into smaller parts, and these parts will be distributed across multiple systems. All this happens automated fashion, and data is stored across multiple systems, and data is processed by multiple systems parallelly. Yes. In Hadoop, data is stored in the form of files. each file again subdivided into blocks. Default block size. What is the size of each block? Previously, it was 64 MB. In the latest version, it is saying 128 MB is the default block size. F1.txt, assume it's some banking data. The size of this file is 200 MB. Into how many blocks? This is the file size. Default block size, right? Assume it is you kept as 64 MB. 64 or 128, even you can keep your own block size. You want to divide the files into what block size? Fixed size blocks. The fixed size blocks you can also set. Okay, by default, if you are not setting, it takes 128 byte. But if you set, you can set to 100 or 50 or 200 block. The size of the each block. Default block size means 64 MB blocks. So into how many blocks this file is divided? Number of blocks. File size by default block size. File size by default block size. File size means 200 by default block size 64. Means how many blocks you will get? 64. So totally 4 blocks you will get. In the 4 blocks, B1 block, B2 block, B3 block, B4 block. 64 MB, 64 MB, 64 MB. This one, how much? 60, 180, 190. This is 8 MB. 8 MB, right? 8 MB only it lasts, but 56 MB free in this. Yes. Okay. If I take one more file, f2.txt, assume its size is 192 MB. How many blocks? Number of blocks, how many? File size 192 by default block size with fixed size, like 64 MB, default block size assume. 3 blocks exactly. 3 blocks means here B5, B6, and B7. 3 blocks. 64, and 64 totally, right? Yes. And here query, why if 56 MB is free in F1 file, why this B5 data is not stored in B4 when 56 MB is free? Assume if B5 data is stored in B4, you are trying to retrieve f1.txt. You are trying to retrieve f1.txt means you need to combine B1 plus B2 plus B3 plus B4. So if B5 stored in B4, 64 MB, 64 MB plus 8 MB of plus 56 MB of file to data store. Totally how much? 256 MB. But file 1 size was F1 file size is 200 MB. But 56 MB extra data you got means 56 MB F2 is like telecom data. Whenever you are trying to retrieve this banking data f1.txt, you got f2.txt data also, right? So it's a wrong computation. So every file will have its own blocks. Only the last block only it will be empty. Yes. Every file will have dedicated number of blocks. Okay, if you check here, when we are retrieving, okay, design principles with respect to HDFS blocks, design principles with respect to HDFS blocks, right? Every file will have its dedicated number of blocks. In a single block, no two files data to be stored. I said in before, file one data already stored. File two data you cannot store it. No two files data to be stored. All the blocks will have equal volume except the last block. Just before that, we have seen file one, file two. In file one divided into 4 blocks, except the last one has got 8 MB, remaining all are got 64 MB, right? Except the last block, remain all will have equal value. Once again. Okay. All the blocks will have equal volume except the last block. So we can also configure the block size. By default, I said it will be 128 MB or 64 MB, right? If you're not configuring, but if you configure, you can have your own block size, means the file will be divided into that block size only. So go to the Hadoop install folder. In the Hadoop install folder, there will be conf folder. In that hdfs-site.xml, there will be an empty file. In that empty file, just write this configuration/configuration opening and closing tag. Property opening and closing tag. Name, property name, opening and closing tag. What is that? dfs.block size. Distributed file system, right? dfs.block size. What is the value? This 50 MB if you want, or 150 MB you want, or 200 MB you want, whatever block size, you can just specify that block size. Okay, fine. So that we can configure that block size. Now, I'll be discussing 3 cases now. So if a file is divided into blocks, if the file is divided into blocks, right? Yes. How exactly? Yes, any query?
It's 50 M or it should be 50 MB.
50 M only, yes.
Okay.
How exactly the data storage and data processing is happening within Hadoop, right? See these examples. I'll be discussing 3 cases here. In case 1, if the file is divided into blocks, right? How many blocks and how many systems slaves you have got? If both are equal, if the number of blocks and the number of slaves, if both are same, right? Then full parallelism. You see, lot full parallelism, very high speed. For example, if you have got a file, the size is 240 MB. Assume default block size is 64 MB. Means your file is divided into 64 MB blocks. How many blocks? File size by default block size 240 by 64. It will be divided into 4 blocks. B1 block, B2, B3, and B4. So here, this is your master node. And data, these 4 blocks stored across 4 systems, S1, S2, S3, S4. In 4 systems, 4 blocks are this, they are stored across. So B1 block is stored in S1, B2 in S2, B3 in S3, B4 in S4. So in the master node, name node, master node or name node. It stores metadata information. Name node or master node stores metadata information. It won't store the actual data. Who stores the actual data? The slave nodes or data nodes. They will store the actual data. Metadata means, okay, data about data. So which block is stored in which slaves that. So any file if you take, the file will be divided into blocks. How they will be divided? File size by default block size. So that blocks will be distributed across the slaves. So this is how the data storage is happening. Data processing, right? Observe this data processing. Your job is to process this file f1.txt. So the job will be divided into tasks. Into how many tasks? In Hadoop, always the number of tasks depends on number of unique blocks. How many unique blocks here? 4 blocks, right? The file divided into 4 blocks, so number of unique blocks. Number of tasks in Hadoop always depends on number of unique blocks. Here, how many? 4 blocks, that's why 4 tasks. 4 tasks means T1 for executing B1 block, T2 for executing B2, T3 for executing B3, T4 for executing B4 block. T1 block for executing B1, T2 for executing B2, T3 for executing B3, T4 for executing B4. Who should execute this? Okay, 1 second. Diagrammatically, I'll say. One second. Okay. Case 1, if I'm discussing case 1, right? If the file divided into blocks, if the number of blocks, if it is equal to number of slaves, number of systems, right? I said you got a high speed, very high speed, right? Assume you got 4 blocks, 4 systems. B1, B2, B3, B4, 4 blocks, 4 systems S1, S2, S3, and S4. I got f1.txt file. Assume the size is like 230 MB. Default block size, right? Assume it is 64 MB, means the file will be divided into 64 MB blocks. Into how many blocks, number of blocks the file is divided? 230 by 64. How many blocks? 4 blocks. 4 blocks means like B1, B2, B3, B4. These 4 blocks, this is the master and slave, right? You've got 4 systems, assume S1, S2, S3, S4. B1 stored here, B2 stored here, B3 here, B4 here. This is the master node. Name node we say. It stores metadata. Stores metadata. Means data about data. It won't store the actual data, but data about data. Who stores the actual data? The slave nodes. Slave nodes. We call them as data nodes. Here, master node or name node, f1.txt divided into how many blocks? Okay, 4 blocks. B2, B3, B4. Which block stored in which system? That information will be stored by this master or the name node. S1, S2, S3, and S4. S1, S2, S3, and S4. 4 blocks are stored across 4 systems, right? Yes. Now here, data processing. Data processing. Job is to process f1.txt. Job to process f1.txt into how many tasks? Number of tasks always depends on number of unique blocks. Number of tasks equal to number of unique blocks. How many unique blocks? How many blocks? Why I'm saying the word unique, I'll say. But here, how many blocks? 4 blocks. Means number of tasks are 4 tasks. 4 tasks, T1, T2, T3, and T4. Your job, f1.txt into 4 tasks, divided into 4 tasks. T1 task, T2 task, T3 task, T4 task. T1 task for executing what? B1 block. See here, B1 has got 10 lakh records, B2 has got 10 lakh records in each block. 10 lakh, 10 lakh, 10 lakh, and 10 lakh records in all this. So T1 task for executing this B1 10 lakh records. T2 task for executing this B2 10 lakh records. T3 for executing B3 10 lakh records. T4 task for executing this B4 10 lakh records. So who should execute this T1 task? Which system? Which one? T1 is for executing B1. Which system has to execute this T1? Means executing B1, right? 10 lakh records. S1 only, right? Because B1 is present in S1. S1 system 1 only should execute this T1 task. System 2 only should execute this B2. This T2. System 3 only should execute this T3, that is B3. System 4 only has to execute this T4. So here, 4 tasks. 4 tasks. T1, T2, T3, T4 are executed by 4 slaves. Are executed by 4 slaves, S1, S2, S3, S4 parallelly. No task is in the waiting state. That's why we say high speed. We say what? High speed. But observe this case 2, right? Case 2. Number of blocks are more. Number of slaves. 4 blocks, 2 slaves. B1, B2, B3, B4. Only 2 slaves, S1, S2. Less speed. We observe less speed. If the number of systems or slaves are less, blocks are more, right? Less speed. In Hadoop f1.txt. f1.txt, right? f1.txt. 230 MB. The file size, a file with the size 230 MB. The file will be divided into multiple partitions. We call them as blocks. Default each block size, assume it is 64 MB. We'll configure it. So into how many blocks, into how many blocks the file is divided means 230 by 64 means 4 blocks. 4 blocks means B1, B2, B3, B4. This 4 blocks, the file is divided into 4 blocks. This is master and slave architecture. Master and slave architecture. Sorry. Here, what is that? Only 2 slaves, but blocks are 4. Slave means systems. Systems, nodes. S1, S2. This is master. These are slave nodes. These are slave nodes. How these 4 blocks are distributed across these 2 systems means B1 here, B2 here, B3 here, B4 here. The blocks are distributed across 2 slaves. So here F1 dot text B1, B2, B3, B4. B1 stored in S1, B2 stored in S2, B3 in S1, B4 in S2. B1 in S1, B2 in S2, B3 in S1, again B4 in S2. Okay. So here, how exactly the data storage, right, means the file divided into blocks distributed across the slaves, right, and data processing. Data processing, right, means job to process f1.txt into tasks, number of tasks. In Hadoop, always the number of tasks depends on number of unique blocks. Number of unique blocks. How many unique blocks? How many unique blocks? 4 blocks. 4 blocks means 4 tasks. 4 tasks. Job to process f1.txt. T1, T2, T3, T4. T1, T2, T3, T4, right? T1 for executing B1. T2 for executing B2 10 lakh records. B3, B4. Who should execute this T1 task? B1 is present in the S1. So S1 only should execute this. Who should execute this T2 task? S2. B3 is present in S1, so S1 only should execute. So T1 by S1, T2 by S2. T3 again by S1, T4 by S2. So here I've got 2 systems, S1, S2. S1 should execute a T1 task and T2 task. S2 also, sorry, T1 and T3. See, S1 executing T1, again S1 executing T3. S2 executing what? T2 and T4. When T1 is executing here in system 1, T3 will be in the waiting state. When T2 is executing in the system 2, T4 will be in the waiting state. Means here T1 and T2 only are executed parallelly. T3 and T4 are in waiting state. Once T1 and T2 execution finished, then only T3 and T4 will be executed. Means some tasks are in the waiting state. So that's why we say less speed. But but if you see that case 3, if we observe this case 3, right? More blocks, only one slave. Only one slave is there. You have got 4 blocks, only one slave. No parallel processing. 240 MB file, default block size 64 MB. 240 by 64, 4 blocks. 4 blocks stored within the, okay. 4 blocks, all the 4 blocks stored by a single system. All 4 blocks are stored within the single system. B1 by stored in S1, B2 also in S1, B3 also in S1, B4 also in S1. If you see the data processing now, job to process f1.txt divided into tasks, into number of unique blocks. How many unique blocks? 4. So 4 tasks. T1 is for executing B1, T2 for executing B2, T3 for B3, T4 also. Who should execute T1? S1 only. T2, S1 only. T3, S1 only. T4, S1 only. Here all the 4 tasks are executed by only one slave, sequentially one after the another. That's why no parallel processing takes more time. See this in case 1, 4 tasks executed by 4 slaves. Full parallelism. Assume each task takes 1 hour. 4 tasks takes only 1 hour only. In case 2, 4 tasks executed by 2 slaves, 2 systems. If each task takes 1 hour, for executing 4 tasks, it takes 2 hours. In case 3, please be in mute. Case 3, 4 tasks by 1 slave. T1, T2, T3, T4. It takes 4 hours. Right? So what is your observation here? More systems, more speed. Less systems, less speed. Only one system, no parallel processing at all. But here you may ask a query, right? If you observe this case 1, T1 task assigned to S1, T2 task assigned to S2, T3 to S3, T4 to S4. 4 tasks are executed by 4 systems parallelly. Suddenly the system goes down, assume, as they are machines. If any one system goes down, 2 drawbacks you observe. 10 lakh records are lost, that is B2 block is lost. B2 block is lost, that is one. Second thing is this T2 task is failed. T2 task is failed means entire job also failed. How Hadoop is going to overcome this kind of problem? If 10 lakh records are lost means huge loss. If the data is sensitive data like banking data. So for that we have got the concept of replication and fault tolerance in Hadoop. Replication and fault tolerance in Hadoop. Replication means duplication. Default number of replications, how many? 3. Means 3 times duplications allowed. But if you want to increase or decrease the replications, you can also configure it. So to solve that previously, what is that? Data is lost, job is failed. So using this replication and fault tolerance, right, we can. Replication means replication f1.txt file.
Sir, one question.
Yes.
Can you give us one real-time implication of changing the default block sizes and also this replication value? Like, what are the circumstances which is this default block size?
Default block size, right? By default, if you're not configuring, right, the empty file, hdfs-site.xml file, it's an empty file. If you're not writing anything, by default, it takes 128 MB block. Your file is going to be divided into 128, 128, 128 pixel size chunks called blocks. But I doesn't want 128 MB size. I want my own size, like 100 or 200 or 50 or how much you want. All right? How much we want, but also we can configure. How to configure, right? Go to Hadoop folder, conf folder, there hdfs-site.xml. It's an empty file. Just write that 4 lines. What is the block size you want? That way. Before dividing the file into blocks, first that it reads what should be the block size. It should be divided into what block size it reads, and it will divide f1.txt. So here replication or duplication, you got 192 MB if the file size is 192 MB. Into how many blocks it is divided means 192 by, assume the default blocks as I have taken is 64. 3 blocks. 3 blocks means B1, B2 and B3. Here replications are duplications. B1 duplicated by 3 times, B2 by 3 times, B3 by 3 times. Totally 9 blocks. Totally how many blocks? 9 blocks here. Duplicated by 3 times. Now this is your master. These are your slaves. Systems. How these 9 blocks are going to be distributed across these 3 systems. B1, B2, B3. And B1, B2, B3. And B3, B1, B2. So 9 blocks across these 3 slaves. So f1.txt is your file name. Into how many blocks? 4 blocks. B1 stored by S1, S2 and S3. B2 also by S1, S2 and S3. B3 also by S1, S2 and S3. B4 also by stored by S1, S2 and S3. Data processing now. Job to process f1.txt into number of tasks, always divides into tasks. Number of tasks equal to number of unique blocks. Here you will understand why I have taken the unique blocks here. How many tasks here? How many unique blocks? 3 or 9. Unique blocks are 3 blocks only, right? Remaining all are duplicated blocks. So here 3 only. T1, T2 and T3. Job to process f1.txt into 3 tasks. T1, T2 and T3. T1 for executing B1, T2 for executing B2. Who should execute this T1 task? As B1 block is present in S1, S2 or S3, all the systems are eligible to execute it. B2 block also, all the systems can execute it. But assume master node has selected S1 only to execute the T1 task. Assume master node has selected S2 only to execute T2 task. S3 only for executing T3 task. So T1 task by S1, T2 task by S2, T3 task by S3. When these three tasks are executed by the three systems, right, parallelly, if any one system goes down as it's a machine, right, then do you see any data loss? Still that B1, B2, B3 present in a system 1 and system 2. There is no data loss. And this T2 task you can assign to either S1 or S3. This T1, T2 task can be assigned to S1 or S3. So T2 task to be assigned to S1 or S3. What is the criteria followed in assigning the task to a slave? Okay, fine. So T2 task should be assigned to system 1 or system 3. What is the criteria followed in assigning the task to the slave? That is one query. One more query. Here T1 task can be executed by S1, S2 and S3. Why S1 only is selected? Why not S2 or S3? T2 task by S2. Why only by S2? Why not S1 and S3? What is the criteria followed, right? Yes. Observe. 4 steps criteria is followed here. 4 steps criteria is followed, right? Observe that what is the 4 steps criteria in assigning the task to the slaves. What is the criteria followed in assigning a task to the slave? S1 executing T1, S2 executing T2, S3 executing T3. Suddenly S2 is down. Then this T2 task should be assigned to S1 or S3. What is the criteria followed means 4 steps. Master node selects the slave which is highly configured among this S1 or S3. Means which has got a high hardware configuration. If both are equally configured, then second one is master node selects the slave which is more ideal, more free among S1 and S3. If both the slaves are free totally, master node selects the slave which is nearest to it. This nearest to it means master and slave can be in different countries, different states, or different cities, or all they can be within the same lab. Assume if both are equally near, then master node selects the slave which has good health status. Even though they have got same hardware configuration, the health status, now and then there were some problems with the hardware or software, right, with one system. So which has got a good health system to that it will be elected. Or if there is no, if they have both have got good health status, then master node select any one slave randomly. This is what the 4 steps criteria. And what do you mean by fault tolerance means if multiple tasks executed by multiple slaves, if any one system goes down, then this task will be allocated to any other slave. This process is called fault tolerance. Multiple tasks are executed by multiple slaves. Suddenly, if any one slave goes down, then the task will be assigned to which is advantageous having the bigger block size or smaller block size. So even if you want to configure the block size, just when someone asks, right, how we can configure, increase the replications and also configuring block size. Same, go to the Hadoop, the configuration file. Just now we have set the property block size to 50 MB. In the same one more property, replications I want 4. Name replication and what is the value 4. Design principles with respect to replication means replications are applicable only for data but not for metadata. Replication only within the slave nodes but not within the master node. All the same replicas cannot be within the same slave. Means S1 is there, S2 is there, S3 is there. In S1, B1 if you are storing. In S2, B2 is storing. In S3, B3. If suddenly S2 is down, entire B2 block data is lost. So the blocks has to be distributed across. Okay. So if S2 is down, then total B2 block is lost. Which is advantages having bigger default block size or smaller block size? Try to answer. Which is advantages having bigger default size, or assume if you got a file with 900 MB, default block size you can configure into 500 MB. Is it advantageous? Means 900 by 500, only 2 blocks stored in 2 systems. Assume you got 40 node cluster where you are using only 2 slaves. Lesser speed. Instead, if you kept the block size as 64, it was using nearly 15 systems will be running parallelly, right? Correct. More speed you should have achieved. So if I keep smaller block size, like 5 MB means this file f1.txt is 50 MB. Already it's a small file. Again divided into smaller blocks, 5 MB blocks. They are stored across multiple systems. And again retrieving all those. It's a time-taking process, right? So it should not be too small. It should not be too big, like medium, like 128 MB is given, right? So that is what the data storage and processing, how it is happening, right? So that only we will specify the block size, we'll specify the replication and the file, but everything happens internally. What we are, we won't see all this where it happens everything internally, right? Just we'll provide that configuration files and business logic implementation will provide. Okay, fine. So I said this is a course has got total Hadoop in brief, PySpark in brief, and also will be everything goes in Linux environment. Plus, you need to have command on this Python. So the course fee for this is 15,000. In this 15,000 total Hadoop PySpark Linux Python, right? Nearly like 60 hours of Python, so 60 hours, right? 60 to 70 hours of Python will be in core Python code and advanced will be discussed. You can attend any of my regular batch, morning or evening. As I said, morning there is 6 AM batch, evening 8 PM batch is there. For the first 1 week, it will be at 5 AM in the morning. Later it will be at 6 AM. For this, at first 1 week, it will be at 6 PM. Later it will be at 8 PM. You can attend this Python. It's 15K. If it doesn't want Python, only Hadoop, PySpark and Linux, the fee structure is 12K. Fine. You can see that Python course content also. Right. Python basics, operations, operators, IDs, flow controls, looping, strings, lists, tuples, sets, dictionaries, functions, modules, packages, errors and exceptions, file handling, object-oriented programming, regular expressions, database connectivity, datetime, OS module, graphical module, Excel workbook, data analytics, introduction to data science, Pandas model in brief, NumPy model in brief, Matplotlib model in brief, right? And don't worry about the software. I'll be providing you the software, right? Yes. So you'll be getting the recorded session of each and everything, Python videos, this Hadoop PySpark, all videos you'll be getting, right? It's clear notes, whatever the notes clearly, what you can see, right? Everything, the notes is clear with the comments. And a WhatsApp group will be created, right? For if you got any error, you can just take the snap and keep in the group. Anybody can answer, right? I'll be answering. So So we'll meet next Saturday, right? But next Saturday, the link will be changing. So you need to get enrolled, right? For next week, we'll be entering with the technicals, right? Hadoop architecture, storage and processing architecture I'll be discussing. Yes. So,
what time this class going to be?
so the timing of this batch, like, I'm sorry. Yeah. So Saturday 2 hours, it's Saturday 4:30 to 6:30. Sunday also 4:30 to 6:30. The timing of this batch.
Sir, I've been in connect with 720721247 for the last 3 days. I'm really having a hard time to get the confirmation on this course plus the Python during the weekdays, the one you just mentioned, the evening. Sorry, the morning one at 6 o'clock. They are not giving me, and they are giving me really hard time
Yours is
to get that
yours is a US. You are from US time zone,
right.
so they are unable to reach you, right? They will be calling daily, right, to the restaurants.
No, on WhatsApp. No,
No,
I've called them multiple times, and I have actually left them multiple messages on WhatsApp. They're not giving. Is there any other number? 720-721-2427.
You just message now. They will call you now.
Okay.
Just to give a message, or you can give a call to them.
I've been doing this for like 3 days, sir. I haven't got the confirmation.
You just give a call, your name.
Mahesh.
You are facing problem. You are unable to reach them. Okay. So you just give a call after half an hour. I'll just intimate them. Yes. Just to say your name. They'll identify.
Okay. So for the full package, I would like to get enrolled with Python. So I know the weekends doesn't change from now it is 5:30, but it is changed to 4:30. And the weekdays, I can have that class in the morning at 6 o'clock,
Yes.
right?
Yes. So this Wednesday, right? This Wednesday it's going to start, right? On both evening and morning match in the Wednesday. This coming Wednesday, right? Yes.
Oh, the Wednesday. Okay.
We are going to start from this Wednesday. Morning and evening batches are going to start.
Okay.
Yes, Hari B, right? Is anyone from the beginner, right? Everything from this ground level to the advanced level will be discussed, and you people also will be interacting with me. If you got any queries, you can ask me. I'll be just extracting it with multiple examples, right? No need of any basics, right? Here, everything I'll be covering the basics, right? Python, Linux, and everything, whatever required, everything I'll be covering, right? It's in brief.
So, sir, are you going to share any videos after the class if in case we miss out any of the classes?
See, 1 second. See here. Every session video you'll be getting, right? Python nearly like 60 to 70 videos you'll be getting. PySpark also you'll be getting every week a video. For example, today's video, as today's like a Saturday and Sunday, right? By tomorrow morning you'll be getting the video of today's session. So every week immediately you'll be getting that day or the next day you'll be getting the video, right? For example, today's video you'll be getting by today night or by tomorrow morning, right? You can go through. If you are miss any one day, you can just go through that. You can attend the next session, right? Yes. You'll be getting the video that day itself. Today now it's 6:30, right? By 8 o'clock or 9 o'clock, you will be getting the video. So once, okay, you can see in the chart, right? 1 second. Can you see in the chart? See, there are some contact details provided. Google Pay number, Phone Pay numbers for the payments, and that payment details are shared. And also the contact details, right? Of 3 contact details are provided. Can you see 3 contact details are provided, right? You can contact those 3 of this if you want to get enrolled, right? And can you see the demo videos? Can you see the demo videos link? Yesterday's and today's video links are given. Yesterday's demo video you'll be seeing in that. Today's video you'll be getting, right? Your mail. And once you got enrolled, everything, all the videos you'll be seeing in your Google Drive itself. The course content you can see, all you can copy that entire message, right? The course content link, the demo video link, the payment process link, right? Yes. Okay, fine. Any other queries, right? Anyone? So Python attending, right? Morning and evening batches both are available, right? If anything is there, if anything, think that if anyone, if you are that office team, they'll be busy with callings, right? If they're unable to respond, okay, means even if you, sometimes what happens, even if you don't forget to share the screenshot of your payment to the mail ID provided, durgasoft online training @gmail.com. Then only you will be getting the link for this next class, right? Still, if sometimes what happens, if someone still even after doing payment, still if they didn't get the link, right? In that case, they can just message me or ping me before the session start on this number, right? I'll be providing it. Okay.
So one question, apart from morning and evening about this Python, in between any other uh,
This week,
hours?
these are the batch, but next coming weeks, right? Like morning, some other timings batches are going to start. Still, if you want to shift into
Okay.
that other batch in the coming days, if any other batch, like night 9 p.m. will be starting, and the morning like
9 a.m. or something.
8 a.m. it is going to start.
Oh, okay.
8 a.m. in the morning or night 9 p.m. it is going to start. So if you want to get later, if you want to shift into that,
Oh, okay.
shift. But meanwhile, attending this and later, if you want to shift into, you can shift.
So that the Python you mentioned core and advanced.
Yes.
So whatever the topics actually given in the training content, so all those the content going through, right, sir?
So that is the people who are enrolled, especially for Python, will be attending those batches, right?
Mhm.
Along with that, you people will be attending, right?
Yes.
Then I'll be covering all the topics.
Okay.
Yes. For them, okay. Fine. Any other query, anyone? Yes.
So this weekend, Saturday and Sunday, 2 hours, sir, 4:30 to 6:30 going to.
Yes, next week onwards.
Okay.
Fine. So if I'm done with your queries, I'll sign off for now. Meet you next week, right? So get enrolled for getting the videos and these notes and getting added into the WhatsApp. Fine. Okay. Thank you all for your time. Meet you next week. So Harry, there is no need of any system configuration. You can, I'll show you, right? And any system you can run this software, right? There's no specific configuration. I'll be providing the software to your Google Drive. So you'll be downloading and you will be executing there from there, right?
So
Yes.
system configuration like 4 GB laptops.
4 GB means the slow, a little bit slow it will be. If we have got 8 GB RAMs, it will be a little faster. But okay, minimum like 8 GB or minimum or 16 GB. If you have got, it will be fast. But if you got less RAM, right, the speed will be less. After typing the command, getting response, it will be taking a little bit time. If you have got good
Okay.
RAM like 8 GB or more than 8 GB, immediately after typing the command, you will be getting that result.
8 GB is minimum, sir. RAM size.
RAM size 8 GB means it will be better if you have got lesser it, you can also extend it by keeping, there'll be multiple slots will be there, right? You can also extend it. But if you have got less than also, you can work, not a problem. But only the speed differs. Okay.